So guys, let us understand that how static NAT solve the real world problem. So let us say that you have a Google corporation which is maintaining its private network protected by the firewall device. Alright. Now we all access our Gmails, right? So have you ever thought that where is Gmail application actually running? Where all your emails are being saved? Alright, there should be some machine which is doing all that stuff. So it is the Google corporation which is maintaining a machine called Gmail server, and it is this machine which is maintaining the Gmail accounts or all the Gmail data of hundreds of millions of users. Obviously it would be distributed machine, so let's not go there. Let's keep things simple in order to understand network address translation. So this Gmail server would obviously have an IP address. So Google has chosen to assign a private IP address to this Gmail server, since Gmail server is one of the machine which is running in the private network of Google, right? So Google hosts its public Gmail server on one of its internal server on the private IP address 10.0.0.0.10, and Google announces to the outside world through domain name server that its Gmail server is hosted on server with public IP address 100.0.0.10. So now Google has purchased one more public IP address from its internet service provider by paying some fees, by paying some monthly money, and let's say that that public IP address is 100.0.0.10. Public IP addresses are not free. Alright, so anybody who purchases public IP address has to pay the fee to the internet service provider. So now in order to provide an access to the Gmail server to the rest of the world, Google has purchased an additional public IP address. And the Google has announced to the rest of the world that, hello, if you want to access Gmail, that is gmail.com, then please access this IP address 100.0.0.10. Alright, so anybody who ever write in its browser www.gmail.com, the domain name server or DNS resolution would come into picture, and it will resolve this URL to the public IP address 100.0.0.10. So basically all rest of the world would going to access the Gmail server at this public IP. Alright. So let us write this public IP somewhere here, 100.0.0.10. So now millions of users in the world access the Gmail using its public IP address. So let's say we have a user who is sitting somewhere on the internet with a public IP address 128.0.0.1. Alright, so this is some user with a public IP address connected to the internet, and therefore it has public IP address. Now when this user wants to access the Gmail, the packet generated by this user would have a source address equal to its own address, which is 128.0.0.1, and obviously the destination address would be 100.0.0.10, because this user knows that in order to access Gmail server, he has to access the Gmail server at this address. So obviously the destination IP address in the IPv4 header of the packet would be 100.0.0.10 IP address. So this is the packet which is coming from this user. Alright, and this is the snapshot of the packet before it crosses the firewall device of the Google. Now Google has installed a rule on its firewall device, and now what is that rule? Rule says that, I'm writing the rule in simple English words here. Later we will see that what is the formal way to configure this rule on a firewall device. So Cisco has installed this rule on the firewall device, which says that if source address of the packet is 10.0.0.10, then change it to 100.0.0.10 for all the packets which are going from inside to outside. Alright, so this is the rule. Now, as I said that once the user installed this rule on a Cisco ASA firewall device, its untranslated rule, that is the converse rule, will also be installed, right? So its untranslated or converse rule will be if okay, let me write this rule in red color. So converse rule will be if destination address of the packet is 100.0.0.10, then change it to 10.0.0.10 for all the packets which are coming from outside interface, and force that packet to go from the inside interface of the device. So this is the converse rule. So now, since this packet is hitting on the outside interface of the Cisco ASA firewall device, the converse rule would going to be applied on this packet. And the converse rule says that change the destination IP address of the packet from 100.0.0.10 to 10.0.0.10. So this would be the untranslated packet, because we have applied untranslated rule, that is opposite of what actually user has configured on Cisco ASA firewall device, right? So this is untranslated packet. I am writing it as UNX, untranslated packet, whereas this was original packet. All right. So once the packet has entered into the private network of the Google Corporation, its destination address would be 10.0.0.10, and the private network of the Google Corporation knows how to route this packet based on the destination IP address. So this packet eventually reaches the Gmail server. All right. So the end user never knows that actually he is accessing the machine which is sitting on 10.0.0.10. All he knows that he is accessing the machine which is sitting on 100.0.0.10. All right. Always remember, the private addresses are never exposed outside the private network. Nobody knows what is the private addressing scheme of various machines inside the private network of an organization. Now, Gmail server will generate some reply. What would be the reply packet would look like? Obviously, swap the source and destination IP address of this untranslated packet. That would be the reply packet that will be generated by Gmail server. Now, this reply packet has to reach to the original user. And when this reply packet crosses this, hits this ASA firewall device, since it hits the ASA firewall device on the inside interface, therefore the original static NAT rule will be enforced on this packet. And that rule says that if the source address of the packet is 10.0.0.10, convert it into 100.0.0.10. So this would be the translated packet, TX. All right. And you can see that public network knows how to route the packet using public IP addresses. The destination IP address in this translated packet is a public IP address, so it will be eventually routed by the internet to the eventual end host machine, that is the end user. So in this entire cycle, you can see that how external user is actually fooled. He was accessing a machine which is on 100.0.0.10, but actually he ends up accessing the machine which is on 10.0.0.10 because of network address translation. So this is the entire picture regarding how static NAT works. Whenever you access Gmail server, Google Drive, or any Microsoft internal website, always remember that your packet is subjected to network address translation at the firewall device which are installed by those organizations. So Google need not expose its internal intranet information to the outside world. Google need not expose that my Gmail server is actually running on some IP address to the outside world for security reason. Google can restructure its internal intranet and change IP address scheme without affecting the world accessing internal public resources, for example, Gmail server. So tomorrow, if Google decides to change the private IP address of its Gmail server from something else, let's say it decides to change the IP address of its Gmail server from 10.0.0.10 to 10.0.0.20, all Google has to do is to update this NAT rule on its firewall device, right? Other than that, rest of the users in the world would continue to access this device on the same public IP address. All right. So Google do not have to announce to the outside world that, hey, my IP address of this and that server is changed. Please go and update your DNS cache. And the last point, other organization may reuse the same private IP address but map to a different public address. As I said, private addresses are local to the intranet of the organization. There could be some other organization, let's say Microsoft Corporation, which is hosting its web server, and this web server is again running on the private address 10.0.0.2. That is the same address on which the 10.0.10, that is the same IP address on which the Google's Gmail server is running. The only difference is that the Microsoft has to map this private address to some unique public address, which should not conflict with the Google's any public address or any public address in the world. So let's say 100.0.0.11. Right? So for Microsoft, its web server has a private address 10.0.0.10, but mapped to a public IP address which is 100.0.0.11. So you can see that private addresses are very much reusable. They do not have any scope or visibility outside the intranet. So this is how the entire network address translation works. For now, we have just discussed static NAT, and it will take some time to absorb the complete cycle in your mind, because if it is your first introduction to network address translation, you might find it a little bit confusing. But if you keep on thinking about it, that how everything fit together, sooner or later you will get an essence of it. And also one more thing to be noted here is that the diagram that you see on this slide, exact same diagram we will going to set it up as our networking lab, on which we will going to practice network address translation.